All right, good morning and welcome back. So the calendar that we've been looking at from the semester, from the syllabus, has changed because we had a snow day on Wednesday, so we didn't have class together. So I've reprinted the calendar by just picking up everything from that point forward and moving it down one row, which means the dates of all the quests and tests have changed. The final exam date is still the same, but all the stuff that I handed on the first day is one class later, and I reprinted those calendars. So make sure you have a copy of that calendar. They're all on the table. So today we're going to cover slope, and the homework that I'm checking is just what was due on Wednesday. So I appreciate that some people went ahead and read through the section that we're going to cover today and tried to do the homework that we're going to cover today, but that's not going to be due until next class on Monday. And our first quest is now coming up on Wednesday instead of Monday. Any questions on the change in the calendar? And one last thing about that quest, the material for the quest you can see here says classes 1 through 5, which goes up until today. Monday we'll do some new stuff, but that new stuff is not going to be on that first quest, right? Okay, so that is that. Let's come back here and jump in on page 26. 26 is all, this section is all about slope. So let's see if we can get a reader here. Alex, you ready? Number 1?
How do we measure steepness of an object, such as a trail, road, or sketch below of 2 cables, guide wires, running to the top pole. Cable A and part way up pole B. Which cable is steeper?
Okay, so let's take a look at this picture here. So again, we've got the pole, which is the vertical line here, and then cable A goes from this point up to the top of the pole, and cable B starts at the same point, but only goes partway up the pole. So which one is steeper, A or B? Well, clearly A is steeper. And in mathematics, we want to be really precise with these kinds of things. So we're going to talk about a precise way to decide that A is steeper. Maybe the picture is misleading. Maybe it's 2 separate poles and you can't quite tell which one is steeper. So let's be really precise here. So filling in, I guess we can just say A is steeper just by looking at it. But now we're going to be precise. So number 2 says that guy wire A rises blank feet. So how many feet up, just the vertical for wire A, is 10, right? Because it's this 10 right over here. And that's exactly the same vertical distance that A covers. So guy wire A rises 10 feet, while guy wire B rises how much? Just 2.5. That's this piece in here. Over the same horizontal distance. How much horizontal distance do they each cover? It is 5 feet. And so clearly the one that covers more vertical in the same horizontal is the one that's steeper. Okay, so let's move on to 3. God. Okay, thank you. It's Tony, right? It's Tony. I missed like one day of class and I have no idea who people are anymore. You normally wear glasses? Yes. Okay. All right, Brandon wears glasses. I know that part. Okay, so let's start calculating some ratios here. So I'm just going to make up a ratio. I'm going to look at the change in vertical distance divided by the change in horizontal distance. Just making it up. And we're going to do that for A, and we're going to do that for B. So what was the change in vertical distance for A? It was 10, and the horizontal distance was 5 for both of them. And so 10 feet over 5 feet is just 2 or 2 to 1. And so we're going to define the steepness of the wire to be a 2. Just making up a number to decide how steep that wire is. It's a 2. Now, the 2 doesn't really tell me anything until I compare it to some other steepness, like the steepness for B. So looking at cable B, we want the change in vertical distance. What is it for B? It's 2.5. And so then if I reduce, and it's the same horizontal distance of 5, so 2.5 over 5 reduces to 1/2. So the steepness of A is 2, and the steepness of B is 1/2. And so now we can answer this question: which cable has the larger steepness ratio? A. A is 2. A is bigger. And so I guess what we conclude then is that if this steepness number is bigger, then the line is steeper. So A is steeper. Now I said I just made this thing up, this change in vertical over change in horizontal, but I didn't. And I think some or most of you have already seen that calculation in some other math class. What's the name of that calculation? We do the change in vertical distance over the change in horizontal. It's called the slope. And that's what we're talking about today. So we'll define it on the next page. Okay, moving on to number 5. We'll come up here to Alexa. Okay, so let's give this one a shot. So we're going to draw a couple of pictures. So we've got road A. And then I'm going to draw on these 2 dotted lines because those are the horizontal and vertical parts for road A. We don't need to worry about scale at all. I'm just drawing a random diagonal line here. Okay, for road A, what's this horizontal distance? 4,250 feet. That's that piece. What's the vertical? Is 120. And let's do the same thing for B. For B, what's the horizontal? It's 2875, and the vertical, 95. Now, I haven't really worried about scale here, but without doing the calculation, can any of you confidently say which one of these is steeper? Oh, let's see, so which one climbed more vertically, A or B? A climbed more vertically, so does that just make A steeper automatically? No, how come? Yeah, it took longer horizontally. So I really can't look at these numbers and tell you which one is steeper without really doing that calculation. So let's do the calculation. So we'll call it slope on the next page, but for right now I'm just calling it steepness. And according to the definition just up above, which one goes on top, horizontal or vertical? Vertical. Put that vertical one up on top, which is 120. Horizontal on the bottom, 4,250. Take out a calculator and somebody tell me the answer here. How much? 0.028? So that's a measure of the steepness of line A, 0.028. And then go ahead and do the same calculation for B. Upstairs, 5 over 2875. Somebody with a calculator? 031. So the steepnesses are pretty close. These roads are almost equally steep, but one of them is a little bit steeper. Which one? Is B, because we already saw above, if you have a bigger steepness number, then you are steeper. So we'll say something like this. Since the steepness B is bigger than the steepness of A, B is steeper. Okay, let's move on to Abby for 6. Okay, so this is our first definition of the word slope, and it just says it's this ratio, the change in the y-coordinate over the change in the x-coordinate. And I just want to point out, that's exactly what we did right here, right? We just did how much does it change vertically divided by how much does it change horizontally. X or Y, which letter represents vertical, is Y. So we're doing the change in Y over the horizontal, which is the change in X. And we're going to use the two words rise and run. You take how much you rise divided by how much you run. The run is always the left-right part. Rise is always up-down. And here's an important note. As we move from one point to another on a line, that ratio never changes. Let's take a look on the next page. We're going to calculate this slope in a second by taking a look at how much we rise to go from one point to the other divided by how much we run. But the fact is, whatever that ratio is, the rise over run, is exactly the same ratio on that much smaller triangle there. The rise is smaller, but the run is smaller by like exactly the right amount so that the ratio, rise over run, is always the same regardless of where you are, regardless of what 2 points you pick on this line. The ratio is always going to be the same. Okay, so let's try this one here, number 7. Alan? Okay, so let's give this a shot. We've got these 2 points. Which one is which? So this one down here is the -2, -2. And then up here is 2, 4. So I'm going to erase some of these other green triangles that I have and just look at that one. So as we move along the line from A to B, A is this bottom one. Let's add that down here. That's A and the other one is B. And so we want to know what the y-coordinate changes by. So as you go from A to B, from here to here, by how much does that y-coordinate change? Or 1 vote for 6. How much does the y-coordinate change by? Another vote for 6. Vote for 4. What do we think? 6. 6 sounds good to me. What was the y-coordinate at the start? It was -2, and at the end, it's 4. And so how much did that change by? Changed by 6. It's easy enough to count boxes here. 1, 2, 3, 4, 5, 6. But I don't want you to get in the habit of counting boxes. I can give you numbers that are way bigger than these ones. The idea is that we're doing something with -2 and 4. What are we doing with -2 and 4 to get 6? Lauren, finding the difference. Which one first if we're going to say 6? Positive 6. So -2 minus 4 or 4 minus -2? 4 minus -2, that's what we're doing. So I'm going to put that here. Change in y-coordinate is a 4 minus -2, which is the 6 that we get upstairs. Okay, let's take a look at the change in the, oh, okay, so then we can fill in this blank as well. So the y-coordinate changes by 6, and the x-coordinate, again, starting with A and moving to the right to B. By how much does the x-coordinate change? 4. So we'll put a 4 there. If I'm doing a calculation, what can I do with these numbers? Let's do this guy here. X-coordinate starts at -2 and ends at +2. What can I do with those two numbers to get 4? We can subtract them. Which one minus which one? 2 minus -2. So we can put that down here. 2 minus -2 gives us our 4. So the steepness of this line, or the slope of this line, is 6 over 4, which we can reduce to 3 over 2. And slope is something we should be able to find without having a picture in front of us. I'm just going to copy the point B right up here, 2, 4. and say all you need is the coordinates of your 2 points, and then what do you do in each coordinate? What was the main operation in top and bottom? Is subtraction. So we did 4 minus -2 and 2 minus -2. And we can do that without having the picture in front of us. What if we had decided to subtract in the other order? What if I did upstairs -2 minus 4 going this way, and then downstairs -2 minus 2 going this way? What do we get upstairs? -6, downstairs -4, but what do you know when you have two negatives with the division? They cancel. And so we're left with the same 6/4 that we got before. So it makes no difference which order you subtract in. Really, there's only two ways to get slope wrong. Number one, you could mix up where you put the x and the y in terms of top and bottom. Which one goes on top? Is the y. Slope. What do you mean? Mm-hmm. Yeah, you can go either direction. So there's like I said, there's only two ways to get slope wrong. You can mix up which one goes on top. It's always the y over the x. Or you could not be consistent in the order that you subtract. So if, for example, over here, upstairs I did -2 minus 4, just like I wrote, but downstairs I subtracted in this order, 2 minus -2, then we're going to get -6 over +4, which is a negative number, which is wrong. This is a positive slope, right? So just have to keep those two things in mind as we calculate slope. Okay, a little bit of shorthand. Let's come up here to, where are we going up here? Let's go to Ryan. Ryan, a shorthand?
Shorthand notation, that's slope is simple. Three-letter delta, which often represents
Okay, and we also use M to stand for slope. So lots and lots of ways that we've talked about slope so far. There's the word slope, there's the letter M, which almost universally stands for slope. Change in y over change in x. You can write change in with a little symbol delta. It's like the capital D in Greek. So delta y over delta x, or rise over run. Any of those is fine. Let's try number 8. Using the graph, find the slope of the line that contains the points -1, -5, and 1, 5. And go ahead and check your answer with a neighbor or two. Again, the letter that we use for slope is M, so I always start with M equals, and then it's just a subtraction problem. Got to keep in mind which one goes on top. It's always y. So just looking at the y coordinates, I chose to do 5 minus -5. That was an arbitrary choice. I could have done it in the other order. The important thing isn't what order you do the y's in, it's to pick the same order for the x's. So I did 5 minus -5, which means I'm also needing to do 1 minus -1. And then just keep track of your signs. Everything is positive in this case, and then reduces to 5. Questions on that? Okay, we're going to skip over 9 and move to the next page to 10. Megan, can you read 10, please? Okay, so we've got a bunch of tables here, and some of them are lines, but not all of them. So how are we supposed to tell whether or not something is a line? Well, you could plot the points, right? You could plot all 4 points, and if it clearly doesn't look like a line, then it's not a line. What if it does look like a line? If you draw 4 points and it looks like they fall on a line, does that mean they do? I mean, anything you draw is going to be just like an estimate, right? And you might be off by a little bit. And so it might look like they're straight, but really they're not quite all on the same straight line. So drawing has its weaknesses. It's time consuming, and it's just an approximation, even if you take your time to do it. So how about we do this instead? We're going to look at these 2 points right here, and we're going to find the slope of the line connecting those 2 points. And then we're going to look at these 2 points right here, and we're going to find the slope of that line. If this is really just one uniform line, what's going to be the case for those slopes? They better be the same. And if those two work, then we do one last time and check the slope of the line connecting those 2 points. And if they're all the same, then indeed it's a line. But if they're not all the same, it's not a line. So here's what I want us to do. There are 3 different tables up here. I would like you guys to split up the work. So one person in each group can find the 3 slopes in the first table. One person can find the 3 slopes in the next table. And then one person for the last table. So divvy up the work and check in with each other. So what did we observe about the slopes for the first box? They weren't the same. So is this a line or not? No, it's not. So does the slope, what is the slope? The question doesn't even make sense. It's not a line, so there's no slope to be calculated. What about for the next one? I got negative 2/3, and then I got, it's kind of hard to see. Let me erase a tiny part of that. I got a negative 4/6 in the middle, negative 4/6. And then downstairs I got negative 6/9. So are those the same? They don't look the same. They reduce to the same thing. So even if slopes look different, you got to make sure they're in lowest form to decide whether or not they compare, whether or not they're equal. So those, all 3 are exactly the same. So is it linear? Yes, it is. And what is the slope of that line? It's negative 2/3 or negative 4/6, any of them, but let's pick the one that's reduced. Okay, and then for the last one, I got 0/1, 0/2, and 0/3. Are those the same? They are. They're all 0. And Brittany says this is what kind of a line? Yeah, if you plot these points, you'll see that this is actually a horizontal line. It's kind of special. And so is it linear? Yes, it is. And what is the slope? It's just straight 0. 0 divided by anything is 0. Okay, let's move back to Victor for 11. Okay, so we had this picture. You guys created this picture the other day. And so what was happening here? What does this 800 represent? So that's the altitude when we start releasing the air from the balloon. And then what does that 4 represent on the x-axis? Yeah, that's how many minutes it takes until what happens? Until we hit the ground, because at that moment our altitude is 0, and then we just follow this linear path down to the ground the whole time. So we're going to pick 2 points and we're going to calculate the slope. So for example, you might pick this point right here. What are the coordinates of that one? 0 and 800. Now, I guess you could maybe like pick one of these in-between points, but I wouldn't, because that means you have to kind of guess and hope that it's perfectly in the middle. So when I'm asking you to pick points that are on a grid, I really want you to find stuff that's not just on the line, but it's also at an intersection of dotted lines. So for example, what are the coordinates of this guy? That's 1 and 600. Or just as well, you could have picked a point way down here, which is what? 3, 200. Or you might pick this point here, and there's plenty of others to pick as well. So what I want you to do is pick 2 points on this line, not the same 2 points as your neighbors, and calculate the slope. So pick 2 points on the line, but don't use the same points. There are 4 to choose from. Pick any 2, so long as we're not all doing the same 2, and calculate the slope. Okay, so regardless of which 2 points we picked, we might have different looking calculations, but at the end when we reduce, we're all getting the same thing. It's negative 200 in this case. Okay, so let's look at B. What does the slope mean in this situation? Write a sentence in plain English. All right, so let's talk about what this negative 200 means. In order to get my hands on what the interpretation is, I think writing units helps a lot. So that 800 and that 0, the 800 for me up on top. What were the units? 800 was feet, right? It was the y coordinate, which was the altitude. So this 800 up here is feet. Now you might have a different number up there, but whatever you have, it was a distance in feet. It was a change in feet. And let's go ahead and write the units downstairs. I had 0 and 4. What are the units downstairs? was minutes. And so the units for the entire answer must be feet per minute. Feet per minute. And I think as soon as you write the units in, the sentence just about writes itself. What's happening here? Something with negative 200 feet per minute. What's changing at negative 200 feet per minute? Altitude. Your altitude is changing by negative 200 feet per minute. Another way to say that is that you're decreasing by 200 feet every single minute. Your altitude is decreasing by 200 feet every minute. So let's write that. Your altitude is changing by negative 200 feet per minute. And that's a little bit clunky to say a negative 200. So I'm going to put an alternate word here. This is what we said. We said it means your altitude is decreasing by what? By 200 feet per minute. So you can change both the word and the number and come up with a sentence that's a little bit cleaner, but both of them are full credit sentences. Okay. So if you are asked to find a sentence to describe what the slope means, write the units down, and the sentence just about takes care of itself. Okay. I think that's all fine. Let's move on to the last problem here, 12. Let's go to Brittany, 12. Okay. So we had this equation the other day, W equals 7.50h, and we're trying to get some information here about the slope. So if I could make a really quick table here. We made a table the other day for this person. If you work 0 hours, how much money do you make? 0, right? Hours and wages. And if we work, for example, 2 hours, it was $7.50 an hour, $15. And we had a bigger table filled in. But let's just go ahead and find the slope here. Remember, the first guy we treat as x, and the second guy we treat as y. So find the slope here. What goes upstairs? Yeah, the y goes upstairs. So 15 minus 0 over 2 minus 0. So 15 over 2, or 7.5. So the slope is 7.5. And some of you might have already known that looking at the equation. Soon enough, we'll be able to all look at that equation and know the slope is 7.5. But let's include some units. The 15, what are the units for that 15? It was wages, which is measured in dollars. So that was $15. What were the units for the 2? Hours. We made $15 in 2 hours. So the units for my answer here must be dollars per hour. So that means that our wages increase at the rate of $7.50 per hour. Now, there's nothing newsworthy about that. That's a fact that was given in the problem. You make $7.50 an hour, so of course your wages increase at $7.50 an hour. But it's heading us to this idea that that the slope gives us information, and the information the slope gives us almost always has that word per in the middle. Okay, so the group activity starts on the next page. Just a couple of quick things before we jump in there. Number 1, The GeoGebra assignment was technically due last class, but we had a snow day, so it became due this class. Many of you have already submitted it to me, but if you haven't, it's just a reminder, there's that GeoGebra assignment due. Also on everybody's pages, or everybody's table, I handed out a copy of this GeoGebra reference sheet, which I think is a really nice beginner's guide for playing around with GeoGebra, and I'd encourage you to explore. This was made by my colleague, Caitlin Worth. So grab one of those. And then in a few minutes, we're going to have a guest come in and talk to you about the free peer tutoring program that we offer. Her name is Montserrat. She should be here shortly. And the last thing I want to say is about some of these problems that we did with the ratio and proportion. So, yeah, let's just jump here really quickly. This was back on page 22. It's a small thing that I want to add, but it's an important thing. If you took Math 095 here, the introductory algebra class last semester, if you took it with Sandy or myself, we made a pretty big deal about clearly defining variables. If you're going to let x be something, you don't just put x in an equation, you write down exactly what x stands for, and you include a quantity word and you include a unit word. And in my mind, I was doing that, but I didn't actually say any of that stuff when we were solving these proportion problems, like on page 22. So for this example here about female students and male students at GCC, and we were trying to find out how many female students, okay, I wrote the words female and male to help guide us as far as which things go where, but I wasn't explicit at all about what x stands for. I just said x, and then I had the word female next to it. What should I have said? Okay, so let x equal the number of females. Anytime you introduce a variable, you got to tell me what it stands for. Because you might have let x equal the number of females, but somebody next to you let it be the number of males, and I need to know who's doing what. So you got to be really explicit. More explicit than I have been over the first few classes. So I apologize, but last semester you were circling quantity words and underlining unit words, and I should have carried that through this semester, and I didn't include it. So just be really careful. If you are bringing x into an equation, I'm looking for a very short sentence to tell me what x represents. Any questions on that? Okay, so then jump back to the page that we were on before. I think it's 29 or maybe 30. 29 is where the group activity starts. I'll put the flags out. Let me know if I can help.